morning, students. Today we discuss about the continuous of what we discussed yesterday, that is what is meant by mutually exclusive events. Events are subsets of the sample space. Now, what is sample space? When you perform a random experiment, the outcomes that you get, the collection of outcomes that you get is called as the sample space. And in the sample space, if you consider a particular outcome, then that is called as an event, and event is a subset of the sample space. Now, based on this, we are applying axiomatic approach to probability. Now we are going to define what is called as a probability. Probability is of an event A. Suppose there is a random experiment S. There is a random experiment and there is a sample space S. For example, let us consider the possibility of tossing two coins, or one coin is tossed twice. The sample space is equal to HH, HT, TH and TT. This is the sample space. Now we are observing, or what is an event? Event is a subset of the sample space. So we are observing A is equal to at least one tail. That is an event. And A consists of at least one tail, means minimum one tail. That is HT, TH and TT. Minimum one tail. Maximum it can be two tails. So n of A is equal to 3 and n of S is equal to 4. Now in this case, when you define probability of the event A, that is at least one tail that occurs, is equal to probability of A is equal to n of A by n of S, and in this case this will be equal to 3 by 4. Now another axiomatic approach to probability is, I hope you have taken down tossing two coins, n of S, at least one tail. The notes will be provided to you, so no need to worry, notes will be provided to you. Now another axiomatic approach to probability is probability of A plus probability of A complement is equal to 1. That is, probability of the event A that occurs plus probability of the event that particular event does not occur is always equal to 1. And probability of A union B in the sets. What is union? Union is OR. A union B is equal to probability of A plus probability of B minus probability of A intersection B. A intersection B is equal to, A intersection B is denoted by and P of A will be equal to N of A by N of S. And you can very well understand that probability is always a number between 0 and 1. Probability is always a number between 0 and 1. The minimum value the probability can take is equal to 0, and the maximum value the probability can take is equal to 1. Now, yesterday we discussed about some questions about dice. Die and a dice. Die is a plural word. So, die. This is a die. And it is marked as, the faces are marked with 1, 2, 3, 4, 5, 6. This is a die. And when two dice are tossed, that means the face can come up with here 1, 1. The face can come up with 1, 1, 1, 2, 1 on this one, 1, 2, 1, 3, 1 4, 1 4, 1 5, and 1 6. Similarly, the other examples. So this is meant by what is a die. Die is a plural word and a singular word, and dice is a plural word. So this is die. Now let us consider about the axiomatic approach to probability and its application. So P of A is equal to N of A by N of S. Always remember that probability is always a number between 0 and 1. Probability of a particular event, when you perform a random experiment, you get a sample space, and in that sample space you define an event A, and that event does not occur. That is, P of A complement is always equal to 1. P of A union B is equal to P of A plus P of B minus P of A intersection B. Now let us consider the example. One card is drawn from a well shuffled pack of 52 cards. So you have already known, you all know what is cards, playing cards, cheat. There are 52 cards, joker is not included, 52 cards. One card is drawn from a well shuffled deck of 52 cards. If each outcome is equally likely, find the probability that the drawn card is a diamond, not an ace, a black card, not a diamond, not a black card. So this is the question. Now let us have a look about the cards. Now all of you know what is a card, but again I am just reminding you what is the structure of the card. When you say about a card, you have clubs. There are 13 cards. This is black in color, and one is marked as ace. Then you have 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you have a jack, a queen, and a king. These are all black cards. So clubs. Then you have spades, spade cards. Spade. This is also 13 in number. This is also black. It also has 1. 1 means it is ace, etc. And this also has 13 cards. So total number of black cards is equal to 26. Now you have another set of cards, that is diamond. Diamond, 13 in number. This is red in color. It also has 1 means it is an ace card. 2, 3, 4, 5, etc. Then you have jack, queen, and king. This is also 13 in number, and this is red in color. Next you have the set of hearts. Hearts, 13. This is red in color, and you have an ace card. Ace card means 1. Ace card, etc. And you have jack, queen, and king. This is also 13. So you have 13 red cards. So total number of cards in the system, total number of cards in the pack of cards is equal to, not 13, here it is 26. So total number of cards is equal to 52. Joker is not included. Now, Jack, Queen, King. Jack, Queen, King. They are called as the face cards. Jack, Queen, King, they are called as the face cards, and that is 12 in number. 3 plus 3, 6 plus 3, 9 plus 3, 12. Jack, Queen, King. This is called as a face cards. Now this is a, all of you are familiar with the pack of cards, but Joker is not included. Now come to the question. One card is drawn from a well shuffled deck of 52 cards. So that means sample space consists of n of s. N of s is equal to 52. If each outcome is equally likely, that is, when you draw the cards, the probability of drawing the cards are equally likely. Each card can be drawn, the chance of drawing each card is equally likely. If each outcome is equally likely, find the probability that the drawn card is a diamond. So let us define E be the event or A be the event of getting a diamond. Diamond. So what is n of A? N of A is equal to 13, because diamond, the number of diamond cards is equal to 13. So what is n of A is equal to 13. So you can say, what is probability of A? Probability of A is equal to n of A divided by n of S, and that is equal to 13 by 52, which is equal to 1 by 4. 1 by 4. Now, next one. The same question, one card is drawn from a pack of cards, and the question is not an ace card. When you are drawing out the card, it should not be an ace card. So total number of cards is equal to 52. Ace cards, number of ace cards is equal to 4. So you cannot draw any of the ace cards. So what is the possibility? What is the possibility of drawing not an ace card? It is equal to 52 minus 4, that is equal to 48. So let us define B be the event, not an ace, not ace. So n of B is equal to 52 minus 4, which is equal to 48. So probability of B is equal to n of B divided by n of S, and that is equal to 48 by 52. 48 by 52. Now, next question is, one card is drawn. What is the probability that the drawn card is a black card? A black card can be drawn only from a black card, and you can see that how many black cards are there. There are 26 black cards. That is, 13 belongs to the club sets and 13 belongs to the spade set. So what is the probability of drawing a black card? Let us denote C be the event, that it is a black card. Black card. N of C is equal to 26 black cards are there. And probability of C is equal to N of C by N of S. That is equal to 26 by 52, which is equal to 1 by 2. 1 by 2. Okay, I hope you are getting it. Next one, not a diamond. That is, when you are drawing the card, it should not be a card of diamond. Drawn card is not a diamond. Not a diamond means it should not be from the diamond. Diamond, there are 13 cards. So let us say E be the event of getting a diamond card. Diamond. Diamond. A not a diamond. E complement. E complement is equal to not a diamond. That means 52 minus 13 is equal to 39. So probability of E complement means not diamond. It is similar to the chapter set, not diamond. E, I am taking it as diamond. So E complement, I am taking it as not diamond. Not diamond means there are total 52 cards. Out of 52, 13 are diamonds. So 39 are not diamonds. So probability of E complement is equal to n of E complement divided by n of s, and that is equal to 39 by 52. Okay. Not a black card. Not a black card. How many black cards are there? There are 26 black cards are there. So not a black card. Let us take letter F be the event of getting a black card. F be the event of getting a black card. And F complement not black. Not black means it will be red. So n of F complement is equal to 52 minus 26 is equal to 26. And what is probability of F complement is equal to? Probability of F complement is equal to n of F complement minus by n of s. That is equal to 26 by 52, and that is equal to 1 by 2. So you have seen that how to what is a die, what are dice, and about taking the cards, pack of cards. A set of playing cards consists of 52 cards, of which 26 are black in color, 26 are red in color. There are 4 ace cards. There are 12 face cards. Face cards are jack, queen and king. And this is a structure of the pack of cards. Joker is not included. Okay. Now we will do some questions, and before that we will take some formulas. If 2 by 11 is the probability of occurrence of an event. Occurrence of an event. If 2 by 11 is the probability of occurrence of an event, the probability of non-occurrence of the event, non-occurrence of the event So you have studied the formula. Probability of an event plus probability of non-occurrence of the event is equal to 1. Occurrence of the event is equal to 2 by 11 plus probability of non-occurrence of the event is equal to 1, or probability of non-occurrence of the event is equal to 1 minus 2 by 11, and that is equal to 9 by 11. Next question. P of A is equal to 3 by 5. P of A is equal to 3 by 5. P of B is equal to 1 by 5. then P of A union B. A and B are mutually exclusive. Mutually exclusive. Now, yeah, you have studied a formula P of A union B. What is P of A union B? It is equal to P of A plus P of B minus P of A intersection B. But here one condition is provided, that is A and B are mutually exclusive. A and B are mutually exclusive. Mutually exclusive. What is the meaning? A intersection B is equal to null set, or P of A intersection B is equal to 0. So this is equal to probability of A 3 by 5 plus probability of B 1 by 5 minus 0, and that is equal to 4 by 5 is the answer. Because A and B are mutually exclusive means A intersection B is equal to null set, or probability of A intersection B is equal to 0. Next one. If M and N are two events such that P of M is equal to 1 by 4, P of N is equal to 1 by 2, P of M intersection N is equal to 1 by 16. Find, first question, find P of M or N. Find P of M or N. So you should know what is P of M or N. That is, in the set theory we have studied what is OR. OR means union. Find P of M or N. That is P of M union M or N. It is equal to P of M union N. And what is P of M union N? Is equal to P of M plus P of N minus P of M intersection N. And all these values are provided in the question. P of M is equal to 1 by 4 plus P of N 1 by 2 minus 1 by 16. And now you know how to take the LCM. 4, 2, 16. 2 times 1 times 2 8s are 16. 2 1 time 1 2 4 time, then 4 1 1 1. So that is equal to 4 2s are 8, 8 2s are 16, 16. 4 4s are 16 plus 2 8s are 16 minus 1. 12 minus 1 is equal to 11 divided by 16. So that is a probability. Find P of M or N. M or N means M union N, and that is equal to 11 by 16. One more question is there associated, related to the same question. P of P of not M and not N. P of not M and not N. How do you write P of not M? This is equal to P of M complement intersection N complement, and there is another formula, that is 1 minus P of M union N. So you can take a formula, P of M complement intersection N complement is equal to 1 minus P of M union N. Not M and not N is equal to 1 minus P of M union N. That is equal to 1 minus P of M union N. We have found from the first question, that is equal to 11 by 16. So which is equal to 5 by 16. Not M and not N. Completed? Yes, I hope you have completed the questions and answers. Now come to the next question, question number 4. Two students A and B appeared in an exam. The probability that A pass is 0.25 and B pass is 0.45. Probability both pass. (0.1). Find the probability that both will not pass. There are two questions. So what is the question? Two students A and B appeared in an exam. The probability that A passes 0.25 and B passes 0.45. Probability both passes 0.1. So probability of A passing the examination is 0.25. Probability of B passing the examination is 0.45. Probability both. That means it is equal to probability of A intersection B is equal to 0.1. Find the probability that both will not pass. Probability both will not pass is equal to probability of A complement intersection B complement, and which is equal to 1 minus P of A union B. But 1 minus P of A union B is not provided, but you can find out by the axiomatic approach to probability. 1 minus, what is P of A union B? P of A plus P of B minus P of A intersection B. which is equal to 1 minus P of A. What is P of A? 0.25 plus 0.45 minus 0.1. That is equal to 1 minus 0.25 plus 0.45 is equal to 0.7. 0.7 minus 0.10 is equal to 0.6. 1 minus 0.6 and 1 minus 0.6 is equal to 0.4. Both will not pass. Find the probability that both will not pass is equal to 0.4. Once again, I will explain the question. Two students A and B appeared in an exam. The chance that probability A pass alone is 0.25, B passes equal to 0.45, and probability of both passing the examination, A and B will pass the examination, is equal to 0.1. Find the probability that both will not pass. Probability both will not pass can be written as probability of A complement intersection B complement. A not passing, B not passing. That is equal to 1 minus P of A union B. That is equal to 1 minus P of A plus P of B minus P of A intersection B. Substituting the values, you get 1 minus 0.6 is equal to 0.4. Okay. Now, one more question related to the same second part of the question. Second part of the question, only one of them will pass. Second part of the question, only one will pass. Only one will pass. That is, we don't know who will pass the examination, either A or B. We don't know. So, we will write, if A pass the examination, then B will not pass the examination. Only one. If A passes means B will not pass. Or when A will not pass the examination, B passes the examination. Okay. Only one will pass the examination. That is equal to, the formula for this is P of A minus P of A intersection B plus P of B minus P of A intersection B. The formula is P of A complement intersection B is equal to P of B minus P of A intersection B. Only one. Or P of A intersection B complement is equal to P of A minus P of A intersection B. What is P of A? P of A is equal to 0.25 minus P of A intersection B is 0.1 plus P of B is 0.45 minus P of A intersection B is 0.1. That is 0.7 minus 0.2. So, add these two, you get 0.7 minus 0.2, which is equal to 0.5. So, what is the probability that, find the probability that only one will pass the examination, only one. We don't know whether A or B. So, when A passes the examination, B will not pass the examination. Or another condition is, when A will not pass the examination, B passes the examination. And the rule is P of A complement intersection B is equal to P of B minus P of A intersection B. And P of A intersection B complement, here A will pass the examination. P of A minus P of A intersection B. Substituting the values and simplifying, you get the answer is equal to 0.5. Question number 5. A die has two faces. A die has two faces, each with number 1. Each with number 1. 3 faces with number 2 and 1 face with number 3. If the die is rolled once, the die is rolled once, find probability of getting a 2. Probability of 1 or 3. Probability not 3. So you imagine the die. In ordinary case, or usually the dice, the faces are marked with 1, 2, 1, 1, 2, 3, 4, 5 and 6. But this is a special type of die in which a die has two faces, each with number 1. Two faces are marked with number 1. Two faces marked with number 1. So 2 faces, 6 faces are there. 6 faces. 2 faces are marked with number 1. 3 faces with number 2. 3 faces are marked with number 2. And the remaining face, 1 face is marked with number 3. If the die is rolled once, find the probability of getting a 2. What is the chance of getting a 2? So, what is n of s is equal to? Sample space consists of 6x outcomes. 1, 2, 3, 4, 5, 6. And what is the probability of getting a 2? It is equal to n of a divided by n of s. Getting a 2, 1, 2, 3. 3 divided by 6, which is equal to 1 by 2. What is the probability of getting 1 or 3? 1 or 3. That is equal to probability of getting a 1 plus probability of getting a 3 minus probability of getting 1 and 3. Probability of getting a 1. 2 faces are marked with number 1. So, probability is 2 by 6. Probability of getting a 3, 1 by 6 minus. What about probability of 1 and 3? There is no face marked with 1 and 3. Either the face is marked with 1 or the face is marked with 3. So, 1 and 3 means there is no such face marked with 1 and 3. They are mutually exclusive events. So, this is equal to 0. So, the answer is equal to 3 by 6 and which is equal to 1 by 2. Next question. Probability of not getting 3. Probability of not getting 3 means probability of getting 1 or 2. That is probability of getting 1 or 2. So, what is that equal to? Probability 1, your favorable cases 1, 2, 3, 4, 5. 5 out of 6. 5 out of 6. Not getting a 3. Not getting a 3 means getting 1 or 2. That means it is equal to 5 by 6. So, we have discussed 5 questions. The remaining questions will be sent to you and you can post it in the email address that is given to you. So I hope the chapter is completed. The chapter is completed. A few more questions are there and that will be given in your notebook. Study well and have a good day. So thank you.